This is Dustin Headley, and I work for the Institute for Digital Fabrication. And this tutorial is taking vector data out of Rhino and into MasterCAMX for CNC milling. Okay, so first thing we want to do is, this is a continuation of a previous tutorial where I exported geometry out of Rhinoceros to MasterCAM. So I want to open up that geometry that I sent to my desktop. Alright, you can see it appearing now. And let's just quickly go over some of the view controls. If I press Alt F1, that's a fit screen. You can do zoom windows, which is going to fit to the center, or I can do a zoom window here. Alright, for these guys, you can do dynamic rotation, and we're going to go, and then you can set your viewports. So we do Alt F1, we can look at it from the side, we can look at it in isometric, or we can look at it in plan, which is what we want to do. Okay. So now let's get to the milling portion of this. We're going to set our machine type to be mill, and we have this post, the MMD file, which you're going to have to locate in whatever folder you're working in for the software. This is something that you add after the software is installed, and it's going to be particular to the machine that you're setting up milling files for. So this is, I'm sending milling files to our Thermwood through MasterCAM 10, so I have that post, and I'm going to select that, and you're going to see it's going to pop up, and it's going to have a machine definition updated, and it's going to be different from this initial machine group. Okay, so let's start setting up these toolpaths. Now here, in the toolpaths window, we have two sets of operations that you'd probably be concerned with. This set of operations, which is working with vectors, and this set of operations, which is working with surfaces. If you're going, essentially you're going to be exporting geometry from Rhinoceros, either surface or vector data, and you can use these two guys to do that. And another tutorial will go over the surfacing of this stuff, but let's just go through the contouring portion of this. And depending on what you're doing, obviously you're going to use different things. If you want to clear out an area, a pocket toolpath would be more appropriate, but I'll let you explore that on your own time. So we set this guy up, and now this window pops up, and it's asked for chaining. This is set to chain. It's important, and we want 3D. So, and the rest of these guys are pretty much irrelevant for what you're going to be doing. So we're going to take this and we want to zoom in on these guys, and we want to start selecting these vectors. So select, and this green arrow indicates the start point. On the opposite end of this curve there's an end point, which is a red arrow, and in order to save machine time, when I select the next line, I don't want this to start in the same point, because otherwise it's got to jog all the way back, and it's going to double my machine time. Basically, I'm going to be covering twice the amount of area and it's not really necessary. If I hit this little reverse key, I've now sent the start point to the end point to the start point, and you can see this red arrow. And this is something you really want to consider when you're starting to set up your vectors. So I'm going to do this quickly for a couple of these guys, and let's see if I can't. You just press R, you can hit the reverse. Okay, and then let's select a couple of these just to show you what this is going to do to the toolpaths if I select each one of these guys in order like that. Okay, let's be done, check. And now we're here in the toolpaths, this parameters portion of this. Alright, and we need to select a library tool. We're going to hit this guy, and there's all these presets in here, and I've developed my own library, so we can go through here. And these are all derived from different tools. If I go in here and I can set these tools to grab one of these guys, and I can grab that, and if I double click here I can edit it, and I can edit those parameters. But this particular project was done on a VBit, which I have programmed in right here, and let's go in and edit this. And actually I've fooled the machine, but what you would do is you basically set this to 0, and we can build this tool real quickly. And we have this tool number 22, and that's important when you take this to the machine, because the machine has a corresponding queue number for that, and you're going to have to make sure that that's all set up. Our outside diameter is 0.5 for this bit, and the flute length was 1 inch. Okay, And this is all the parameters I really need to adjust. So you can see I have the profile set properly here, and this is a lot of this is going to be dependent on your knowledge of the machine itself and being able to align this thing properly. So I mean, this tool is going to be as fail-safe as physically possible, but ultimately it's your responsibility to make sure that you're running the machine correctly. So I'm going to click OK, and now we've got this bit loaded, and we need to set our feed rates, and we want this to be about 500. That way when we run the machine it'll run properly. And we want to set our spindle speed to around between 17 and 18,000 for pretty much every tool you're going to be using, unless it's otherwise recommended. Okay, so now we want to go into the contour parameters, and there's a couple guys in here that we will need to look at that are important. Depth. If you're doing something that's all in the same plane, it should show you the depth of that cut properly in here. If it does not, you need to go back into Rhino or wherever you're developing your geometry and make sure that everything's set up properly in that area. We need to make sure, depending on what we're doing, that this contour thing is either set to 2D or 3D. These vectors are moving in 3 dimensions, so this is properly set. Lead in, lead out, we want that off, always. Always, always, always. You never want to use lead in or lead outs. And lastly, the compensation, and this is going to depend on what you're doing for particular operations. Excuse me. And so the computer is going to, in this instance, want to compensate left, which is going to move the bit in a direction so that it can mill out this vector and just trace the edge of the line instead of moving along it. And that's handy when you're doing something like cutting out a box or something. You obviously don't want to, you draw a line that represents the boundary of the box, and you don't want to cut along that line, you want to cut outside it. And that would be when you're using this compensation. And you need to make sure you're aware of which way the vector is moving as you set that up. But since we're not using that, we're going to turn that off. And now these parameters are null and void. So click OK. And now it's going to develop our contours geometry. And you can see here already where, and I missed one, how this is adding some extra traveling distance, where this tool is going to have to move back and forth an additional amount. Alright, now let's go into isometric, and let's do an Alt F1, and let's see what this looks like, okay? If we want to make some adjustments at any point, we can come in here and just edit the parameters by double-clicking on parameters. We can edit the tool by double-clicking on the tool. We can edit the geometry in the chain to a certain degree. You can't really add very much, but you can certainly remove. And then if we right-click on this toolpath, we can get a live action preview of what this thing is going to look at. And we can increase the speed of this to 700. So now it's going to, let's zoom in. Now you get an idea what this thing is going to look like. Okay? Alright. And you can play out each one of these documents as you see necessary. I already kind of know how this is going to work. And this is going to advance without any consideration to jog speeds. It does quick move, long distance moves that are very simple very quickly. So. Okay, and then the last thing that we need to do is we need to take this and we need to post this geometry. So we need to take this and we're going to select all operations, and we're going to hit this G1 button. And this is going to ask us to set the post. And we're going to come in here and we're going to just, it's already selected, we're going to hit the check. And we're going to send this to the desktop. Bench surface is fine. We want an NC file. Click save. It's going to come in here and ask us for our material dimensions, which were 48 by 10.5 by 0.88. And those dimensions are important because that's going to set the offset for the machine because of the way that the machine reads the vectors. So you can adjust those actively in the document and set that stuff up. Alright, that's it. Cheers.